Now that we have defined these functions, let's look at some of the properties they have. So as you all know, a circle has many symmetries, and since sine and cosine and derived trigonometric functions are sort of defined using this unit circle, it inherits some of the symmetries. So as you know, as I said, we have this angle here, and then we measure cosine theta as the x-coordinate of this point and sine of theta as the y-coordinate of this point, and we can move these things around, right? And if you notice something, you will see that what happens if you replace theta by minus theta? You get a symmetry, right? Everything is very symmetric here. So how is this symmetry encoded into the functions? Well, note that if you replace theta by minus theta, you get the same x-coordinate, right? It doesn't matter whether you're up here or down here for the x-coordinate. It's always the same. So a negative angle and a positive angle with the same size has the same cosine value. The x-coordinates agree. Is there also a simple relation between the y-coordinates? Well, clearly, it's just mirrored, right? So how do you mirror something? In this case, mirrored in the x-axis. Well, you just put a minus, right? So sine of the negative angle equals the negative of the original angle. Right. So this point up here has the same y-coordinate as this, only with a minus in front. So that's one symmetry. Replacing theta by minus theta, then we could take theta and add pi. So what is pi? Pi is what we usually refer to as 180 degrees, right? So you get something that looks like this. So my original point is this one, if you're confused. And what is then my pi plus theta point? Well, it's what you have up here, right? Going from here to here is 180 degrees, or pi, right? So what are the coordinates of that point? Well, it's exactly the same as this, only with minuses in front, right? So sine of pi plus theta equals minus sine of theta. Cosine of pi plus theta equals minus cosine of theta. What happens if we replace theta by pi minus theta? So this is theta, pi is from here and all the way to over here, right? So minus theta from here would be going backwards up to here, right? Like this. So we get something like this. Again, we have a symmetry. And how is this symmetry reflected in the functions? Well, sine of theta minus pi minus theta equals just sine. So what does that mean? Note that these two points, this point and that point, always have the same y-coordinate, right? And sines are y-coordinates. What about cosine? Well, now it's just mirrored, right? So it just corresponds to minus cosine of theta. So cosine pi minus theta equals minus cosine theta. So I said that you would get an idea of why it was useful to use the unit circle instead of the degree circle, the huge circle. One of the reasons is that you get this very nice identity if you use degrees, right? Because then it's natural to look at unit circles, and you get that you have something with a radius 1, and this is basically a 1 squared, right? Another thing is that the sines and the cosines will have, I mean, everything is just nice here. Imagine that this should have been a function of 360 before anything repeated itself. It would have been much different. It would have been a very slow function.